All right, review for the Unit 3 exponential test. I think one of the biggest things I want to do is a little intervention on how to figure out these little tables and stuff, okay? The biggest thing that people keep doing is, you'll see here in a second. So if I have X and Y, right, I have a little table here. It's 5, 10, 20, 40. You should see off the top of the bat. Is that a phrase? You should see right off the bat what is happening between each of these. 5 going to 10, boom, 10 going to 20. What's happening?
It's multiplying by 2.
Multiplying times 2, multiplying times 2. So 5 times 2 is 10, 10 times 2, it's multiplying times 2. Now, you can easily see this, but if you look at these, you definitely cannot see what that is just with your eyeballs alone, okay? So what I tell you guys to do is divide backwards. But then what you guys do is you're like, okay, this divided by that. This divided by that, and you divide forwards, okay? So here's why it should not make sense at all. Y'all know this is times 2, right? I'm using an obvious example to show why it doesn't make any sense. 5 divided by 10. What's 5 divided by 10? 5 divided by 10 would reduce to 1/2, right? Right, so that's a half. So 5 divided by 10, that's a half. Is this thing getting cut in half? No, that's the opposite, right? So that's the exact opposite thing to do, which is why it should make sense that I divide backwards, which would be 10 divided by 5 is 2, right? 40 divided by 20, 2. So I'm trying to show a very clean, obvious one so that when we get into all the crazy, it makes a little bit more sense. Okay, so now, with that out of the way, the very first question here is this one right here. And all it asks you is the common ratio, right? So to find what the common ratio is, I would take this divided by that, right? And then you get 7.5. And then if I want to double check myself, because it's the test, and I'm like super want to get 100, I could also take this number divided by that number, and it would also be 7.5. And if I wanted to triple check myself, I could do 15 times 7.5 and see if it works. This times 7.5, see if it works. And you could literally 100% know you got the correct answer, okay?
Yeah.
Cool, done with that one. Now, here's the ones, all the rest of these are the meat and potatoes of this entire test of, here's a table, what's the equation? That's the biggest thing, okay? So here's the table, what's the equation? I need my y equals a times b to the x, okay? I'll write that once so that you should have that down in some sort of notes of some kind, okay? And then I have y equals, what is the starting amount for this table? Starting amount is always the 0, so we have 315 is the starting amount, okay? 315. And then the a sub 0, or sorry, that is the a sub 0, the common ratio, okay? You're not able to just look at it. They gave us the a sub 0, but here we go. So I'm going to do the same thing we just talked about. 105 divided by this, you're going to get 0.33333333333. What is that? You should be able to identify that decimal as a, oh, I know what that is. It's a repeating decimal, but if it's 0.3333333, it's the same as 1/3. 0.666666666 is double that. Not 1/6. It's double that, not half of that. 2/3, right? So 1/3 is 33333. 2/3 is 6666666, and then 3/3 is 1. Okay, cool. All right. So now this is 1/3 to the power of x. Okay. The common ratio here is 1/3, but I would be thinking about that I am dividing by 3 all the way through, or multiplying by 3 going backwards. So make sure you keep track of what's happening going up and down and what the common ratio is. Okay. Cool. Now, same thing for this one. Y equals the starting amount is 4. Got it. Power x, I'm just plugging in all the blanks here. I need to find out my common ratio of what it's multiplying by each time. I kind of can just look at this one with my eyeballs and be like, 4 times 5 is 20. 20 times 5, 100 times 5, 500 times 5. Got it. So it's just times 5. Cool. All right. Now, this one. You should be able to look at this and know what's happening. Has to do with the number 10, right? So it's going down, and it's basically losing a 0 each time, if you want to think of it like that, like 450 to 45, if you erase that 0, right, it's going dividing by 10. Dividing by 10, what's another way to say that as far as a common ratio situation? Because I cannot write divide by 10. That's not, nope. That is wrong. What's another way I could write a divided by 10? Dividing by 10 is the same thing as multiplying by 1/10. The whole pizza analogy we talked about halving something is the same thing as dividing by 2, multiplying by a half, dividing by 2. That makes sense, but then when you start getting into a tenth and dividing by 10, that's also the same thing. Cutting something into fourths versus dividing by 4, all that stuff, okay? So what's my starting amount, though? They did not give it to me. What would I do to these numbers? What happens to these? I would have the same number right here, but then when I'm going backwards, I would multiply by 10, which just adds a 0 to the end of that. So now that's the number. And then for the 0th term, I'd have the same number, right? Oops. I'd have the same number right there, but then since I'm multiplying by 10, I'd add another 0. So now I have 4,500,000. Wow. So I'd have 4,500,000 times 1/10 to the power of x. Cool. So there's that one. Next one. I forget what number this is. This is on the next page, number 5. Number 5. Okay. Keywords all in this thing are approximate or estimate or use the data as a model. Okay. This is the table. This is the data. These numbers are real. They were checked. They were calculated. They were measured. Whatever. Okay. I'm going to estimate from here, and that's what the whole point of this part is. Okay. So, what did y'all get for the difference between each of these? Sorry, not the difference. The common ratio. Okay. So this divided by this. What do we get here? Okay. So these are the actual things that I just calculated here. I did 3 decimal places just to make this into a learning opportunity, possibly for rounding. You need to round to 2 decimal places. I have purposely written 3 so we can go through the process of rounding to 2 decimal places. 0.559 is going to round to 0.56. 0.560, that's obvious. 0.561, 6, look at the 1, it stays. 0.568, that is going to be an 8, it rounds up to 0.57. 549, look at the 9, this rounds up to 55, and this is a 4, it stays the same. Okay, cool. So now that I have all of these ratios, do they have a common ratio? Well, they do not have a common ratio. Common ratio is a consistent number that you multiply by. It's always the same. These numbers are not always the same, which is what we knew going into this whole thing. So I'm going to add them all up to get a total of some kind. So we get a total. What's our total right now? We got 1, 2, it'd be about like 1.9 or something like that. 1 point what?
Oh, you mean adding them all together? I got 2.8.
2.8?
I got 3.36.
So it'd be 1, 2, 3. There we go. Okay, so it'd be 3 point what?
36.
36, and then you divide that by 1, 2, 3, 4, 5, 6, and you get what? 0.56. There we go. Ding, 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 ding. Great. All right. So this is the common, sorry, it's not the common ratio. It's the average ratio. Very nice. So that is what I need for my equation now. Y equals the starting amount, which is 71.2 times 0.56, right, to the power of x. Cool, right? That is a very good example of having to do the whole average thing. There's at least 2 of those on the test. But that's not all. It says, that is all. Okay, the next one we're going to extend it. Okay, number 6, don't worry about that. It's the same as all these other ones. Number 7 is right here. 2 more. Growth or decay, it is going down, so this is decay. The number here, I believe, is 0.96 all the way, and then this is 0.95.
Yeah.
Okay, I remember this. I've memorized this one. Okay, so those are all the common ratios. This divided by that, this divided by that, dividing backwards like we talked about. So my y equals, my starting amount is 180.2 times 0.95 to the power of x. Also, I did 0.95 because if you added all these up together, that 0.96 combined with all these 0.95s is not going to be enough to change the average from being 0.95. So I took the lazy man's road there, but there you go. Okay. Now, the logic part here, it wants to know, this is minutes, and this is x, and this is y, or whatever. It wants to know what the value of x is at 30 minutes. What is x at 30 minutes? So minutes, I go down all the way to 30 minutes. I've gone by threes, by threes, by threes. 3, 6, 9, 12, 15. You could count on your little fingers. 15 is whenever x is 5, right? X is 5. 6 would be 15, or 5. 6 would be 15, 16, 17, 18, 19, 20, 21, all the way down to 30, and you get 10, right? Or you know every 1x is 3 minutes. So that means 10 would be 30, or you could do 30 divided by 3, or you could just see that 5 and 15 double both of them. However you want to do that, there's literally 3 different ways right there. But find out whatever x is, and you're going to take that x and plug it in to the x right there, okay? When you do this, you would do 0.95. Somebody get their iPhone calculator out and hold it to the side so I can hold it up for this. This is the first thing that I would enter in here. I'm plugging in a 10 for this right now. Okay, sweet, perfect. So this, can y'all see it? And do they see it at the same time? Okay, cool. So if you want to do this, I would press 0.95 in the calculator. And then there's this x to the power of y button that you maybe have never used on your calculator before. You're going to press that. And what that says is that is x, the number I just led with is that, and the next number I type in right now is going to be y, which is that power of 10 equals, and then there's my crazy decimal. Wow. It's whatever that is. And this number, all of this, times that is what I'm doing right now. So I'm going to go in there and do times 180 equals, there's my number, 107, 107.8. Okay, shake the thing. And that's going to be x is 10, 30 minutes, all that good stuff right there. Okay, from plugging in that 10. Okay, and that's it. Now, the last question has to do with understanding the difference between a model and a table. This is the table they gave you, and then they said the equation of the function model is y equals 1.707, 1.018 to the power of x, okay? Just like we just did here in this question. We were given a table, we averaged some stuff, and we got a model. We got a function model, we got an equation, we got an estimation equation, whatever, okay? They did the same thing here with this. They just did it for us, okay? Now what the question's asking is, what does it say? In the year 1994, the data shows blank, but the model shows blank. So the data shows this, right? That's the table, that's the data, that's right there. And then this is the model. And it's asking, what does this show, okay? How do I find that out? With this table, I got the 0, I got 1, 2, 3, 4. How do I find out what this says for 1994? And this is, again, this is not anything in like this category. I've already taught y'all how to do equations. This is now logic. Like this is not me teaching you anything. This is just your human capacity to understand where things are at and what numbers are going where. What does this all mean in the big picture, right? So the year 1994, the value of x is 4, and it is this. So I would just, to replicate that in this table, how would I get this number from this table? I would try to plug in 4 for x, right? I just would plug in 4. And this is not, again, there's no unit in this year that teaches you how to think through a table and follow instructions, right? I just want you to be able to try and approach it with as much logic as you can, like a puzzle or whatever, to know that I want to find out this year, x is 4, plug it in, right? And then you'll get something, right? So when you plug this in, you do the same thing we just did there, you get 1.833. Okay, 1.833. This is what it spits out for you. Now, which number or which one of these is correct and which one of these is the estimation? Is the table correct or is the equation correct? That's important to understand to be able to even answer this question. Which one of these is a fact and which one of these is an estimation? The table is a fact. They literally measured this. They calculated this. This is real. They had years. They measured stuff. They measured temperatures. They did all this stuff, okay? And then we estimated, right? And this way, every time we've ever talked about averaging stuff, real life is not always perfectly measured every single time. So they estimated here. This is their estimation. This is what actually happened, right? So this is wrong, and they're asking you, how is it wrong? So did the function model overestimate or underestimate the data? I'll say it again. Did the function model overestimate or underestimate the data? It overestimated. Okay, cool, because this is too high, right? They estimated too much, right? But I'm sure at some point they might have estimated too low, and it's going to be changing because this is an estimation. Still useful, but not 100% accurate, okay? That's how all that works. And on the back side, you just had to make your own table, but that was more so of a thing for yourself to just explore around with. And that is it. Done.